Now let us consider a simple differential equation that is linear and separable at the same time. Okay? And see how we can solve it as a separable first, and then as a linear. Okay? So let's first think of it as a separable differential equation. So first we separate variables. Then we are going to get dy over y equals dt. Then we integrate. Well, and then the antiderivative of 1 over y is ln y equals the antiderivative of 1 is t plus constant. But it's not exactly true. So the antiderivative of 1 over y is ln y only if y is positive. But y may be negative, right? Because remember that we just did something like this when we derived the formula for the integrating factor. But when we derived the formula for an integrating factor, we only cared about finding one particular integrating factor. So which means that we didn't care whether we found a positive or a negative integrating factor, and it was completely fine to find a positive integrating factor. U of t was e to the power something which is positive is alright, because we only needed one integrating factor. We didn't want to find all of them. But now our purpose is to find all possible solutions, and we cannot just exclude solutions with negative value of y, well, because there is no reason to do it. So strictly speaking, it should be like this. And then instead of c, I'm going to write c1 because, well, you will see why. Okay, so now let's take apply the exponential function. So let's raise e to this power. So e to the power of logarithm is the expression inside the logarithm, so it's y equals e to the t times e to the c1. Okay, but then notice that if c1 is any constant, then e to the power c1 is any positive constant, right? So if you take the exponential function of any number, then you get a positive number. So this is really e to the power t times c2, where c2 is a positive constant. But this is absolute value of y. So what is y itself? Y itself is, of course, going to be plus minus c2 e to the t. But c2 is a positive constant. So plus minus positive number is any non-zero number. So this would be really like c3 times e to the t, where c3 is a non-zero constant. So is it all? So is it true that any solution can be written in the form any non-zero constant times e to the t? Well, not yet. This is because initially when to separate the variables, we divided by y. But y may also be 0. And if y is 0, if you look at the original differential equation, there is nothing wrong with y being 0, so we just need to check. Is it true that y equals 0 is a solution? Let's see. d0 dt equals 0. Correct? Correct. So it means that y equals 0 is also a solution. So in other words, y equals, what we get is that y equals c3 times e to the t, where c3 is any non-zero constant, or 0. But notice that this can be just written in the compact form c times e to the t, where c is any constant, where c is any constant. I'll just write any real number. Because if c is non-zero, then it can be associated with c3. And if c is 0, then 0 times e to the t is just 0, and 0 is a solution, so is correct. Okay? So, my point being is that the pretty simple answer, that the final answer is that is c times e to the t, where c is any constant. We got it when we solved it as a separable equation, but we went through some complicated reasoning. So let us now see if we can get the same answer by doing it as a linear equation. Because at the same time we can rewrite it as y prime minus y is 0. So then we can find the integrating factor, and the integrating factor is e to the power antiderivative of minus 1 dt, which is e to the minus t. By multiplying with the integrating factor, we know that the left-hand side should be the derivative of the integrating factor, which is e to the minus t times y prime equals, well, 0, because 0 times the integrating factor is still 0. So taking the antiderivative, we see that e to the minus t y is constant. So solving for y, we get y is c to the times e to the t. So in other words, the same answer is found kind of in a much simpler manner. And it is usually true that if an equation can be solved as a linear and as a separable, then it is much easier to solve it as a